10-4 hyperbolas. Hyperbola is a set of points, P, the point P, which is an xy on the hyperbola, in the plane such that from the point P to the focus point, P to the other focus point, if I take the difference of that, the absolute value, it'll equal 2a. A is the distance from the center to the vertex, center to the vertex. So the difference will be that length, be the length of the transverse axis. If it opens right and left, it's this format with the x squared over a squared minus y squared over b squared is equal to 1. If it opens up and down, it's y squared over x squared minus, or y squared over a squared minus x squared over b squared is equal to 1, with c squared is equal to a squared plus b squared. And again, this is my distance a to the vertex, distance c to the focus. To get the correct shape of the hyperbola, we need to find asymptotes of the hyperbola. These asymptotes are lines that approach, not touched or crossed. These asymptotes are boundaries of the hyperbola. This is how we have a difference, hyperbola versus a parabola. Okay? Hyperbola opening right and left, like this. The asymptotes are y is equal to plus or minus b over ax. This is slope, rise over run. Rise is b, run is a. And I hope you can see the run is a on this one. There's my run, that's a. Okay? If it opens up and down, my rise now is a, and my run now is b if it opens up and down. Okay? So there are the asymptote equations. So once you draw the asymptotes, what you're going to do is you're going to find a vertex here, and then you're going to draw the asymptotes, and then you're just going to draw the hyperbola following those. So let's graph the hyperbola. X squared over 16 minus y squared over 4 is equal to 1. I want to find the vertices, the foci, and the equation of the asymptotic lines. Since x squared is the positive one, x squared over 16 is positive, minus the y squared is negative, this has to open right and left, because this is the form. It's in that x squared minus a squared form. A squared 16, b squared is 4. In this, a squared plus b squared is equal to c squared. A is 4, b is 2, c is the square root of 20. So if I were graphing this, I'd say, okay, my center is 0, 0. Opens right or left. So if I go a units right or a units left, I'll be at the vertices. So my vertices, 4 units this way or 4 units this way. So I would start with that. My focus would be 4.5 units. So 4.5 over this way, 4.5 over that way. The asymptotic lines would be the equation y is equal to rise over run. The run is a, so it's b over a. B is, wherever I found b, b squared is 4, so b is 2. So 2 over 4. So it's plus or minus 2 over 4, or 1 over 2. So from here, I go 2 over 4, and I put a dot there. 2 over 4, dot here. So then I would have an asymptote here, an asymptote there, and then I would just graph it from here, just go like this, and follow the asymptotes. Like I said, go 2 units up and down, 4 units right and left from the center. And you're done. 2, graph the hyperbola y squared over 25 minus x squared over 9 is equal to 1. Give the vertices, foci, and equations of the asymptotic lines. Now, since that's a positive, it opens up and down. It's the form of the y squared minus the x squared. A squared is 25, b squared is 9. So c squared is 34. A is 5, b is 3, c is about 5 point something. And I know it's closer to 6 because 5 squared is 25 and 6 squared is 36. So if you're going to take a guess, just make sure it's 5 point something close to 6. So if I were graphing this, I would say, okay, my center point, 0, 0. I know it opens up and down, so if I go a units up, which is 5, and a units down, I will be at the vertices. So at 0, 5 and 0, negative 5, I'm at my vertices. My focus would be somewhere in here, would be at 0, 5.8 and 0, negative 5.8. The equations of the asymptotic lines are y is equal to rise over run. My rise is A, so my run is B. So it's 5 over B is 3. So it's 5 over 3. So it's plus or minus 5 over 3. So I'd go up 5 over 3. And there's one line. Up 5 over 3. There's my other line. And then just draw it so it follows the asymptotes. Okay, and like I said, going up 5 and 3 to the right or left from the center would give me the asymptotes. Number 3, find an equation of the hyperbola with a center at the origin, one vertex at 7, 0, and one focus at 12, 0. So when you're looking at this, you should, and I like to draw it out. So when you're looking at this, you should say, okay, I have a vertex at 7, 0. And I have a focus somewhere here at 12, 0. My center is at 0, 0. So this distance, 7, is my A. This distance, my focus, 12, is my C. So A squared is 49. And c squared is 145. So remember, on this one, a squared plus b squared equals c squared. So b squared is 95. So my equation, opening, when you look at that, what I drew there, that would be the major axis. So I know it would have to open right and left. So I hope you know the format of opening right and left. So the equation then would be an x squared minus a y squared, and it'd be x squared over a squared, 49, minus y squared over b squared is 95, is equal to 1. And you're done. Give equations of the asymptotes. First of all, let me try to graph this a little bit for you. Let's look at this. Let me do a t-table. When x is 1, y is negative 4. When x is 2, y is negative 2. So here's a couple of them. Okay, so I'm at 1, negative 4. 2, negative 2. 4, how about for x? I'm at negative 1. 4, negative 1. So wherever 4, negative 1 is. Okay, and you could pick smaller numbers, but what number can't you pick here? And I hope you can see that you cannot pick x cannot equal 0, and y also cannot equal 0. So my asymptotes would be the axes. X equals 0, y equals 0. Okay? I started picking points there, but what if I picked x is equal to negative 1? And then I get y is equal to 4. So negative 1, 4 might be here. So it looks something like this graph right here. So it's in quadrants 2, because this is my first quadrant, second quadrant, third quadrant, fourth quadrant. 2 and 4. There. The second and the fourth. Equations of the asymptotes. X is equal to 0, y is equal to 0. Translations of hyperbolas. The same idea. HK is the center now instead of 0, 0. And see how your equations changed? It's now H and K. That's the only difference. So let's try an example. I have a sample problem here. Y minus 2 quantity squared over 36 minus x minus 1, that quantity squared over 25 is equal to 1. That format has to open with the y squared being first. It opens up and down. So I know it's up and down. And if I were drawing this, I would say, okay, I'm going to draw my center first. My center is at 1, 2. So at 1, 2, I would draw my center. Okay? And I said it already opened up and down because the y squared is positive. 36 is a squared. 25 is b squared. So if you do the formula, a squared plus b squared equals c squared, you'll get 61 for c squared. So a is 6, b is 5, and c is 7 point something, close to 8. I told you the center was 1, 2 already. I know it opens up and down. So if I go a units up or a units down, a 6, I will be at my vertices. So if I'm at the point 1, 2, and I go 6 units up, I'm at the point 1, 8. If I'm at the point 1, 2, and I go 6 units down, I'm at the point 1, negative 4. I'm taking my y and adding or subtracting 6 units from it. Okay? So that's what I did here. The focus point is C. So I'm going C units up or C units down, 7.8. So from this 2, I'm going to add or subtract 7.8. 2 plus 7.8 gives me 9.8. So I'm at 1, 9.8. If I subtract 7.8 from 2, I'm at negative 5.8. So 1 minus 5.8. And that's the math that I did. So from the center, if I go A up and B over, so I go rise of A and a run of 5, I will be at one of the points for my asymptote. Or if I go 5 over this way, I will be at the other point. Rise over run. Okay? The center. 1, 2. And then now draw it. You have a vertex, follow the asymptotes. Vertex, follow the asymptotes. And you're done. Next one, find the equation of the hyperbola with a center of 1, 1. So my center is 1, 1. I have a vertex at 3, 1. Vertex at 3, 1. A focus at 5, 1. Focus at 5, 1. When you graph this, I hope you can tell that it will open right and left. Okay? All on the same horizontal line. Okay? A is the distance from the center to the vertex, so from 1, 1 to 3, 1, that distance is 2. Center to focus going from 1 to 5 is 4. So that's my C. So C is 4, C squared is 16. A squared is 4. So B squared is equal to 16 minus 4, which is 12. So the equation opening right and left, my x squared goes first. So I have x first minus my h, so 1 quantity squared over a squared is 4, minus y minus 1 quantity squared over b squared, which is 12, sorry, is equal to 1. One through 34, every other odd, and then 35 through 63, every other odd.